Hey everyone, so here's the last part, part three, for the lesson 6 notes. So what we're going to do is apply your information on how to solve exponentials to this word problem. So we're going to talk about Newton's law of cooling. So here's the formula. Now, will you need to memorize this formula? No, you do not need to memorize. You just need to make sure you know what each of the variables represent and how to plug in the numbers. So let's talk about what do each of these variables represent. So T on the end is what we call your final temperature. This T sub naught or T sub 0, we also call this T naught. This is your initial temperature. Then T sub R, that's what we call room temperature. Now E, remember that is a button that is on your calculator. This R is the rate of cooling. Now when we do our rate here, it should be probably already in a decimal form, so we should be okay. And then T is going to represent time. So please make sure you may need to pause the video to write down what all of these variables represent on your notes. Okay, let's see how we're going to apply this Newton's laws of cooling for our example here. So example 3 says you are driving on a hot day when your car overheats and stops running. It overheats at 280 degrees Fahrenheit and can be driven again at 230 degrees Fahrenheit. Now, if the rate, or R, is equal to 0.0048 and it's 80 degrees Fahrenheit outside, how long in minutes, that's kind of key thing, how long in minutes do you have to wait until you can continue driving again? Now, first, what we need to ask ourselves is, well, here's our question. How long in minutes do you have to wait? So we need to ask ourselves, okay, what variable are we trying to solve for? Well, when they ask for how long, that should represent time. So we are trying to solve for t. That means every other single variable, except for e, we're going to plug in a number. So here, let's first talk about the final temperature. So we're asking ourselves, well, what do we want our car to have a final temperature of so we can drive? Well, we want to have a final temperature of 230. So we plug 230 in for our T. Now, what is the initial temperature of our car right now? Well, the car overheated at 280. So that is our initial temp. Now, minus the room temp. Now, here in this case, the room is actually the outside temp. Okay, so the outside temperature right now is 80. So I do minus 80. Now, E stays E. Our rate, they already told us what that is. So we keep it as that decimal. But notice there is a negative in front of the R. So make sure you have that. So we have negative 0.0048. Remember, we're trying to solve for T. And then we have this plus T sub R. So that is going to represent our room temperature again. So that is 80. Okay, here's what I'm gonna have you guys do. I'm gonna have you pause the video so you guys can try to solve this equation on your own. Okay, let's see how you did. Now, this is actually very similar to our example 2C and 2D that we just did. How we solve these equations, we're gonna do the exact same thing on this example. So first step, what we need to do is isolate our base. Remember, our base here is E, so we must isolate it. Now, in order to isolate the base, okay, what we're going to do is, I notice 280 minus 80, we can actually simplify this. So I'm going to go ahead and do that. So I have 230 equals 250 e to that negative 0.0048 t power plus 80. Now, continuing on, I'm going to add or subtract first. So in this case, we are going to subtract 80. So we should get about 150 equals that 250e. Okay, next I'm going to divide both sides by 250 to get that e by itself. Now, actually, when you plug this in, the 150 and 250, it does give us a decimal that terminates. Oops, I think I did something wrong. Oh, it should be 200. Sorry. So let me redo that. So it looks like, oh, I did this incorrectly. I'm sorry, guys. This shouldn't be 250. And you may be wondering, oh, that's not right. Yeah, it's 200. because 280 minus 80 should give us 200. So I'm going to change that. There we go. There we go. So we're actually dividing by 200 here. Sorry about that. Okay, let's retry that. So we got 150 divided by 200. We do get a terminated decimal, so we can change it as a decimal, or if you want to leave it as a fraction, you're more than welcome to do that. So we do get 0.75, and then e to that negative 0.0048 t power. Now, just as we talked about in the last two examples, we are going to rewrite this in log form. Now, remember, to rewrite in log form, we got to think about what's the inverse of e. Our inverse of e is natural log. So I start off with the base. So I do natural log. Now we go away from the base. That's our outer. So I do natural log of 0.75. Then I go towards the base, so towards the exponent, so negative 0.0048 t. Now, I do need to get t all by itself in order to solve. So what I'm going to do is divide both sides by this negative 0.0048, and I'm going to plug this into my calculator. So when doing that, remember, because of that natural log is in the numerator, I click on natural log 0.75, or if you left it as that fraction, make sure you close off the parentheses, then divide it by negative 0.0048. And so here, let's go ahead, we can round to the nearest minute, because that's what we want here. So it looks like it would take about 60 minutes. And we use minutes because when we go back to the problem, it does talk about how our units is in minutes. So it takes about 60 minutes approximately for the car to cool down from 280 degrees to the 230. Okay, make sure you work on the homework assignment. It is going to be online. It's a Schoology assignment. If you have any questions, make sure you come in before or after school or during Tiger time when I'm available, or you can also email me. See you guys later.